The microphone wasn't on before. We need to remember that it's on. Avoid embarrassment here. Hello, please find your seats. We're going to get started very soon because we have a very tight schedule today. This is the Dnssd working group. Welcome. We have Suzanne Wolf as Jabberscribe, and we have Tim, but a different Tim. Alternate Tim. Tim Superscript 2 here to run this, manage the slides, take notes, and generally make sure I manage to run the working group correctly. Great, and we have a Jabberscribe. We have Jabber going. There we go. Here's the note well. Okay?
Yeah.
Yeah, okay.
You're driving.
Okay. Here's the agenda. I'm going to talk for a few minutes here. That introduction and note well we just did. We're going to do agenda bashing. Oh, you know what? This agenda is a little out of date.
Oh, that was when I came off the website.
How long ago?
Like minutes ago.
Really?
Yeah, but it was on the tools page. Maybe tools page busted. So.
Oh well, no big deal. The difference is we're going to do the threats document first, and then the two documents that Stuart's going to talk to us about, and then Dave Thaler's going to talk briefly. Hold on just a second.
Yep.
Right, and I have okay, this may not have the document status page. Anyway, I'm going to give you an update on our document status. The reason to do the document status is, as you'll see, we have potentially, depending on how things go today, we have potentially 3 working group last calls that are going to start after the meeting this week. Yeah, I'm not sure that that's...
Yeah, because I grabbed the PDF about an hour or so ago.
Huh. Okay, oh, I see. Yeah, there's a next steps document that's missing. Okay, so here's a document status. The Dnssd hybrid document. We're going to get a quick review of the changes in the -01 rev. And then whatever time we have left in the 20 minutes allocated for that document, we'll answer any questions and have any initial discussion. In particular, when we get to that document, I want to try to identify somebody who's going to go through and see how this document matches up against the requirements of RFC 7558. We did a rough job of that review once. I want to have somebody from the working group identified as doing that review. We're also going to be looking for a document shepherd. That's the hybrid doc. The Dnssd push document, we'll get a review of the changes in the most recent rev of this document. I need to identify somebody who's going to review it against the Dnssd hybrid specification just to make sure that there's no conflicts, even though it shares authors, there probably aren't any conflicts, but we'd like a little external review just to be sure. We're going to look for a document shepherd for that document as well. And then finally, Andrew Sullivan's MDNS DNS interop document was discussed. The working group last call completed before the Prague meeting. We discussed the comments from the working group last call at the Prague meeting. Due to an oversight, the document was revved, but Andrew thought he had uploaded it and hadn't. He's got it uploaded now. So while we're not discussing that at the meeting today, we're going to ask for a brief final review by the working group. It has essentially passed working group last call, but we want to make sure that these revs are acceptable, and then we'll send that one to the IESG. So it's actually 2 working group last calls and a working group last call plus. Now, having said all of that, those are really our primary documents coming out of this working group, right? We've got a solution, we've got a corollary to the solution, and we've got the interop document, which was one of the key things that we were chartered to take on. That means we haven't finished our work, but we're getting pretty far along in it. We've handled many of the items in our charter at this point. So those 3 documents are likely going to be ready for the IESG. What we want to do is think about, is there anything else that's required to meet the requirements for an extended scalable Dnssd, which is sort of our primary charter point. If you look at the charter, that's sort of the top sentence in what it is we're supposed to be accomplishing. So I'm going to start that discussion on the mailing list. We're going to see if there's anything else that we want to take on. If not, then we'll deal with the document that Dave Thaler is going to talk to us about today. We'll have the threats document, and that may be all we need to do. And then finally, one small consideration is issues out of the MDNS DNS interop document that need to go to the DNSOP working group for solution, right? If there's anything that's identified as, gee, this really needs a little bit of work, we'll pass it off to DNSOP working group. So there we are. Questions? Okay, if not, Stuart, if you will come to the mic. Oh, threats first. I'm sorry, you're right. Threats first. Doug. Sorry, I knew I put them together and it's based on which direction.
Yellow box, pink box. Well, my name's Doug Otis. I'm sorry, I was helping Hosni to put together a comprehensive collection of the threats we both looked at. So one of the things we did in this latest update is we tried to provide some terminology. And gee, what's going on? It's very annoying. Well, what we try to do is we try to add some terminology to help clarify what we were saying. And so we try to come up with some terminology, and in doing so, we stepped on our own feet, you might say, and that some of the terminology we used, I lifted from the home architectural documents, and they included the term site local, which was a misuse of that term because it had a prior definition that had a different meaning. So what I did is I issued some corrections to our draft that I put in that email I just sent to the working group, where we changed the terminology to say inner site addressing or whatever you want to call it, but not to call it that same term, which has a predefined definition that's different than what we wanted. Some of the concerns that we were looking at is how do you prevent visual spoofing? And we have the interop that Andrew Sullivan put together seems to differ in how this might be addressed within a security-related document. My concept is we try to limit the number of proliferations of sub zones that you have within a primary zone, where you don't have as many conversions possible from going from MDNS zones that might be expressed to having things that are placed into DNS proper. And so one way of minimizing the differences, if you included spaces and punctuation and whatnot that could be confusing to anyone looking at that, would be to simply substitute an underscore at those locations so that it becomes a bit more readable and more clearly defined as being that's the end of the string. that seems to be fairly controversial. I'm not sure why, but anyway. The other thing I needed to correct was the term ULA, and that as I said, I defined it incorrectly here. The other area we focused on is resource exhaustion, and that it's really hard to say how many services you're going to have in a zone. If a service is related to host names, you might have a lot of laptops that are considered separate services identified that way. And so you could have a large number of resources on the same node. And so what we looked at, what was going on within the DNS Ops working group, and refer to those solutions back to what might be done as a way of mitigating some of these problems that could occur. The one that's currently in place now is essentially a thing called rate limiting, and that's been implemented in within Linux, and it's been implemented within Bind. So they're available today. They're just not an RFC draft that you can point to. But when you look at how do you scale that out, if you have to rate limit an indefinite number of sites that are spoofing their addresses, then that becomes an impossible thing to do. You can't rate limit against something that you don't have the resources to even identify. So one solution to that problem was to then use cookies to allow have the client effectively keep track of what resources you're trying to assign. If you don't see your assignment coming back to you in the form of a cookie, you just ignore it, and that allows you to scale in that problem space. You don't have, if you have a resource limited router that doesn't have infinite amount of memory, then this is a solution that works in that environment. So we referenced the DNS Ops cookie. That seems to be rolling along. I think that'll be adopted too. So that the rate limiting, which I think has limits in what you can use in terms of scaling, and then of course the DNS cookie, which I think provides you the next level of scaling. Wow. Anyway, if anyone doesn't freak out from all the flashing. So I guess, are there any other issues open that we uncovered that should be corrected, or?
I'm going to switch the technology here on us. See if this computer is better. Because I think it's actually.
Do you want to discuss this while the slides are not up? Okay. So I'm Andrew Sullivan. I have some grave worries about the terminology in this document. I think that and it's not a terminological problem. The reason I have worries about the terminology is because they reveal deep confusions about the environment that we're talking about. So it seems to me that you talk about the DNS as though it's both one system and multiple systems at the same time. And I think what you need to be clear about is that if you're talking about the global DNS, then the global DNS does not include the DNS that you've configured like in your local environment that has like a different tree than the public DNS. That's not part of the public DNS. That's just like using the DNS as a separate private one. And that's a different system. It's the same protocol, but it's a different system. It's not the DNS. And I think that I think that there's a deep confusion in here because you talk about like in the root and so on, but that's not what the problem is. The problem is that you don't have a consistent namespace that you're talking to in these private DNSs. And then you've got MDNS, and that's a different protocol with a different namespace, and then you've got the public DNS namespace. And I think by clearing up this confusion, some of the threats that you've been concerned about with respect to spoofing and so on reveal themselves to be inevitable problems of having multiple namespaces. It's not like a tiny problem. It's a built-in problem here, and that I think that the threat that you've identified is a consequence of having multiple namespaces, and you can't actually mitigate that threat. You can't actually solve that threat. You can only mitigate it. So I think that you start from that weak foundation, and having done that, I think a number of the other problems that are in the draft, and part of the reason that I find it very difficult to follow is because you're starting from a set of premises that I think are manifestly false. You should probably talk into the mic.
Within the queue. I agree with everything you just said. However, I guess my quandary is, how do you express this in the draft? Because the terminology you're saying that you have to limit yourself to doesn't really adequately address what's happening in real life.
Private DNSs are a private route. That's what that is. It's an alternate route. It's okay that you have an alternate route sometimes, because if it's an alternate route that is used just by you, it's not a threat to the global namespace because it's not public. But it's an alternate DNS system, and I think you need to make that perfectly crystal clear in the document, because it's totally confusing to me right now.
Actually, I don't think that's how it's going to be used as a result of how this gets deployed, and that it may be in a private route, or it may be within a global route that has to be trimmed or pruned.
What is this global route that has to be trimmed? That's the public DNS. There's only one global route. It's the public DNS.
True, but you can have multiple views of that zone, right? In other words, you can have
those are alternate namespaces. That's exactly my point.
Well, what do you call the namespace that's been filtered versus the namespace that is not filtered? What do you call that? How do you describe that?
So they're not filtered namespaces. If you're in the right context, you get that entire namespace. You get all of the results from there, and it's a completely different view of the network.
Okay, but what do you call it?
What you need to do is call it a separate namespace. I don't know exactly what terms you need to use there, but it needs to be clear that this is not one namespace with two views. It's not. It's a different namespace.
The terminology I've seen used many times is like split view.
Right. Split view or split horizon. People say that, yes.
And I'm okay with that, but
okay.
When you just start describing that, it makes it very difficult to then talk about this essentially the same zone that's going to be filtered, if you will.
No, there's wait, you just stepped right into the cake on the ground that is the confusion here. It's not essentially the same zone anymore. They're different zones. If you got two views configured in bind, and one is an internal view and one is an external view, one of those gives you the answer depending on how you query. And that is not essentially the same zone. Those are different zones in effect. You could make the same thing happen by configuring a different route. So this is a trick that is used of the network, but those are different namespaces because they give different answers. Like they lead to different results. It's not just that they give different answers, because it's not like it's a different A record. I don't care about that. The point is, when you go to that resource, like you visit that thing or whatever, you get to a different thing at the other end, the thing that you're trying to consume. I get the point that you're trying to make, that the thing you're consuming is a different end result. You get a different web page, or you get a different, resource, or you get a different answer. That is, sometimes you get one of them, it doesn't exist. In the other case, you get led to there. But they're different namespaces. And not being clear about how they're just different namespaces, they have the same name and they're different namespaces, causes the confusion that you're tripping over here. Now, not everybody agrees with that way of describing it, but the reason you're having trouble, I say, is because you're having this confusion, and you think it's a problem of terminology, but it's not. It's a conceptual confusion.
I guess I get confused when you say it's a different namespace, although it carries the same base names. In other words, nothing has really changed in terms of the overall namespace. Some of it is missing.
No. It's not missing. It's that you're in a different universe.
Okay.
One of them has the little mustache and the other one doesn't.
how would you, what terminology would you use to describe the one with the mustache and the one without?
I don't know. We can call it bizarro world and not, or we can call it we can call it the private world and the public world, or I mean, you know, you can call it the external view and the internal view, which is what a lot of people call it. But the point is that they're completely separate things. It's not like they're sort of the same. They happen accidentally to be unified, and that's actually where the security problems come from.
What I found in some of the drafts talking about this namespace, they use the term inter-site communications. Should we call those inter-site namespaces and avoid the word site local and all this other stuff that has all the terminologies that we get into conflicts with there as well?
I really, this is why I started this comment by saying this sounds like a terminological dispute, and it's not. It's a conceptual dispute, and it just happens to be clearest when you talk about the terms. I really don't care what we call it, but the point that I'm trying to make is that you need the draft right now, it seems to me, is stumbling over this problem because the concepts are not clear. And maybe that's just because you didn't have the right words, but I don't think so, because it doesn't seem to me that the way the rest of the draft hangs together suggests to me that you've got this idea that it's really completely radically different namespace that happens to just carry around the same word, just like bark of the dog and bark of the tree. That's not the same namespace. They're different concepts.
I hear what you said.
Paul Hoffman, I'm going to, I think, agree with Andrew in a different way, which is that the theme of this document are security issues and concerns. I think that those security issues and concerns only come up when you misunderstand the fact that there are two namespaces that one entity is sort of thinking of as alike. I think if you don't make that mistake, there's probably almost no content to your document. So what you are describing is, in my mind, if you have made this conceptual mistake, here are all of the security results. That's a reasonable thing. I don't think that's something I've never seen anything like that documented in the IETF as completely. I sometimes see things like that in the security consideration section of a document saying a common misimplementation will do foo, and that has a lot of really bad consequences. But I think that if you separate out the idea of mixing namespaces in one head, there really isn't much content to your document. Things like, oh, the names might look alike. Well, they don't look alike because they're in completely different namespaces. Or there might be a collision here or there. They have only collided because you've pushed together two dissimilar things. That's just a thought. So maybe look at whether, or the working group can look at, if it's going to adopt this document, about whether changing the basis of allowing or not allowing the mixing of two things would leave anything in the document.
Well, can I take an exception to what you're saying?
Sure.
Because in reality, if you're in a campus environment or wherever you might be, those namespaces do in fact mix, and that you're going to have both of them that are going to be available to a large population of people that potentially could be confused by these things, even though they may not appear in the quote unquote root, global root within that campus or within that large enterprise. They do appear. And so how do you discuss those concerns that do affect a large population? And to say that those don't matter because they're not in the global root, I think is missing some of the points.
Okay, so I don't think that they ever mix. You started off that statement saying that they mix. I don't think that they actually ever mix. I think one entity looking at both of them at the same time might make a mistake on that. And that's fine. And I would say that many of the things in your document do come out of that, but not that they are mixed. They aren't mixed. They are separate namespaces, where separate's a very important word.
Okay, but within, say, the enterprise namespace, you have similar concerns that you would have in, say, the global namespace.
Yes.
And so I guess one of the things that I concern myself with, is how do you make sure that that enterprise namespace is kept reasonably safe? And what techniques can we use to keep that environment safer than it would be otherwise? Because you also have the administrators trying to keep track of this stuff, and something that's self-defined. It's really difficult.
So I don't see much of your document covering being valid for just an enterprise namespace. I see it only being valid when there is someone looking at the enterprise namespace at the same time as they're looking at the global namespace, and there are names that look alike. But if you're doing a document for just the enterprise namespace, most of your issues don't come up. There's not confusion. So anyways, I'm suggesting think about it in those terms, and it may be the working group wants to deal with the larger issue of, oh, a lot of people sometimes mix things up, and once they do, here are the results. I'm not sure that that's going to be the case, though.
I guess I deal with the enterprise environment too much, but I know that we use in a large enterprise, we do use a lot of internal namespace.
Sure.
And there are a lot of troubles that we're having with that. And so a lot of my thinking is how do we keep that space clean?
Okay.
And
That doesn't seem as relevant to an IETF document, I would say.
Well, except you're trying to bootstrap a local environment, and you're going to try to expand this into a campus. And those kinds of issues, I think, do come into play that would be something that would impact how the IETF sees this moving forward.
Okay.
I'm just trying
Others
to.
might disagree. Okay.
Okay, well,
Yep.
Maybe we don't care about it then.
I'm just going to say that I'm
May,
Rand
please.
Atkinson. I'm just going to say that I agree both with what Andrew said and with what Paul Hoffman said. And to the extent there is content in the document, it is significantly obfuscated. I'm sure that's not intentional, but I have read the document, and to me, it reads like a confusion. And to paraphrase Rumsfeld, if you start from a misapprehension, you can then proceed quite logically to a misconclusion. So at a bare minimum, the document needs a rewrite.
This is Andrew again. And so I'm trying really hard to like offer you useful critique here, because I read this document and I found it very confusing, and I really do think that this conceptual confusion is at the base. But let me just like note what you've got here, and maybe this will make it a little more clear, because actually I don't agree with Paul that that the enterprise namespaces are out of scope here. The very problem that we're here talking about is a variant of that, you know, namespace problem, right? Because MDNS with DNS resolution and with non-DNS resolution has the same characteristics. So I actually think that this is well within the issues that we're supposed to deal with. But look, you've got global namespace, which is global unique namespace accessible for resolution within the root domain, which is already wrong, but that's just a minor issue. But then you've got a realm-specific namespace accessible for resolution referenced from a subdomain that may not be within the root domain. So you say here, you see, you've got the definition where it actually says, well, it's not in the same tree. That's what that says.
Right.
Well, what that means is a realm namespace has an alternate root. If you rewrite that, that's what it means.
Well, no, I agree with that.
Okay, so now what you're talking about is a threat that results from using the same protocol from the same computer to access two namespaces that look protocol identical, but that turn out to be like rooted in two different roots.
Right.
And you know, I think that the answer to that, the IAB said many years ago, when I wasn't on it, fortunately, that, you know, there's a single namespace for the internet. And the reason it said that is because of this problem. This is an instantiation of what happens when you've got split brain root. You shouldn't do that, it hurts. And so, so I agree that, you know, there's a serious problem here. We can't just tell people, look, we know you've been doing this forever, but actually it's really, really dangerous. But in fact, we ought to tell people, you've been doing this forever and it's really, really dangerous, and here's how. And it's good to write down it's really dangerous even though everybody does this, right? People used to play with, like, in my primary school, the teacher used to make plasticine for us out of asbestos and water because asbestos was inert, right? Well, it turned out it's not, and it was a bad idea. And learning that it was a bad idea to have powdered asbestos in the air of grade schools, that was valuable. And I think we should tell people that. And similarly, I think we should tell people here, what you're doing is playing with rotating knives. Stop it.
Well, I'm in complete agreement with everything you just said. And I understand the concerns that everyone's having and that you're not to do this, but we're doing it anyway. So how do you describe that in terms of a coherent security concern and expressing it clearly enough that people aren't confused by what you're trying to tell them? I guess I can create a separate section that tries to split those concerns out.
You just asked for security considerations for rotating knives. I think the answer is, don't do that. That's the security consideration.
But people are going to do it anyway.
So now what the advice at that point is, and if you're going to play with rotating knives, do not be surprised if they sometimes cut off your hand. That's okay. It's your network, your rules, you get to play with it that way. What you can write down here is a useful piece of advice, which is, if you do this, you expose yourself to these risks. You don't want those risks, don't do it. That's good advice. And I don't think there's anything wrong with it.
So I'm gonna cut in here briefly and encourage everyone to take this discussion to the mailing list. We're out of time for this particular presentation. Thank you, Doug, and thanks for all the comments from the room. I think we do need to continue it to get the fundamental difference in approach to how to write this down straightened out. And I hope everybody will continue to participate so we can get that straightened out. Stuart.
We have two documents that I'm going to talk about today. We're kind of doing them in reverse order because hybrid references this one, so it makes sense to do this first, even though this is the less mature of the two documents. We have some updates for the DNS push notifications document. In discussions about how this works, there was a good suggestion that a hybrid proxy, as well as discovering services that are available on that link, which is in a sense the import side of the equation. It's taking data into the unicast DNS namespace. Once you have that entity on the link participating in multicast DNS, it can also serve a useful role of serving configuration information to clients on that link. And those clients are consuming the data from the unicast namespace. So in a sense, these are two sides of the coin. One is on the import side, one is on the export side. But there's a lot of utility in co-locating that functionality in one software entity. If this hybrid proxy is going to be a software function of your IP router, kind of like the way a BootP relay agent is, then it makes sense for it to do both. I'm talking about the wrong draft. I think we got them in the backwards order.
Or do we?
Yeah, we're going to do the push one first. Okay. So push was a new document. We had the old UDP-based LLQ mechanism, and working with Tom Pusateri, he came up with quite an inspired simplification of that using TCP. So we had draft 00. We did a couple of updates since then. due to discussions at the last IETF, I forget who, but somebody pointed out that a reconfirm operation would be good, because on the local link, multicast DNS has a way, if you try to print and the printer's not responding, you can feed that information into the distributed caching algorithm and say, hey, that data you have cached seems like it's wrong. In the case of a remote client through the hybrid proxy, we would like that feedback mechanism. So we've added a reconfirm operation, added some discussion of the load, the burden that these clients put on the server, and some guidance about how to not put excessive load on the server. Added some more words clarifying when a client should share a single TCP connection for all of its operations, while also acknowledging that there may be cases where that's not possible. There may be independent implementations running on the same device that don't know about each other, in which case you can't expect them reasonably to share a connection, but a client should do that when it can. I think due to Andrew Sullivan's suggestion, we added a reference to the eDNS keep alive option for DNS to specify that an idle connection should not be closed after 30 seconds, and general guidance about protection for long-lived TCP connections. And then finally, also in response to discussion at the last IETF meeting, we added a mechanism for a server to tell a client why the connection is being terminated. If a server is overloaded and wants to shed some load, if it simply tears down connections, the clients are likely to treat that as a network failure and reconnect, which makes the problem worse. So we added a mechanism for a server to say, don't bother me for 15 minutes, and then close the connection. So that's the summary of what has changed there. I'd like to have discussion of the changes if people have suggestions for other things that should go into the document. We have this question about whether we want to do a working group last call on that. In my mind, part of that hinges on what implementations we have, because we have at least 2 implementations of hybrid proxy, and that document is a couple of years old, and we've all had a lot of time to think about it, and that's fairly mature, and I'm fairly confident about that. The push notifications, on the other hand, is relatively new, and we believe in rough consensus and running code. So until we have running code, my personal view is it might be premature to rush to last call on something we haven't implemented yet.
Hi, Stuart. Ray Bellis, ISC. The eDNS Keep Alive was the vouchers individual draft you referred to there, has been completely replaced with a DNS Keep Alive draft with somewhat different semantics to Paul Vouter's original draft. And that's already been to last call, and I think advanced the ISG as of a day or so ago.
Okay, so I will need to fix that. Do you think it is suitable for what we want to do here?
I'll need to reread the doc to look at it, but happy to go through. If you have any questions on how that's supposed to work, let me know.
I will check that document and I'll see how it fits into what we're doing here. Thank you. Okay, the comment from the chairs is yes, the document is relevant. It seems like I need to do a search and replace and check it for sanity. And yeah, it won't be quite a mindless search and replace, but conceptually.
I'm sorry, going back to the first document we just discussing. This
you're talking about the push notifications?
Yeah, the push notification. One of the things that seemed possible with that approach is that it provides congestion control that may become problematic within a multicast type of network, or if you're trying to do it over UDP in a wireless network. If you're trying to pass large amounts of data through, that could be a problem, where you potentially run into large RR sets that may be expecting large blocks of data to go through without error. And so it seems one of the advantages you might have if you're running it through TCP on a per client basis is that might provide you the necessary reliability and rate congestion control that you wouldn't get if you're trying to do this over, say, multicast or something else. And so what are your views about co-opting that to replace what is normally done with multicast DNS. In other words, providing a way of browsing the network.
I thought I understood what you were saying there, and then you lost me at the end. I thought you were saying the push draft should include some text about how TCP congestion control can control the load on the network,
Well,
but then you started mixing multicast in.
Yeah, I'm sorry. Right now, if you want to browse the network, normally you're doing it through multicast, where you ask for essentially everything that's out there and allow the person to select from that menu what it is they want to do.
Well, no. You don't ask for everything that's out there. You ask for everything that meets your needs to respond.
Right, your certain services. But those services may be significantly large. If it's a...
When you mean the service is large, or there are many services?
The many services,
Okay.
well, falling in that category that you're requesting. So you might get a large response. And
Well,
that,
no, you won't get a large response. You will get many responses.
okay.
If there are 10 printers on the network, they don't all get together and prepare one response. You get 10 responses from the 10 printers saying, yes, I'm a printer.
Well, but if you're looking for RR sets that may be large, meaning that, as an example, you have a browsing function that you have within Dnssd, where you can ask for the pointer records to all the services available.
When you pull out your iPhone and press the AirPrint button, the query it sends out on the network is a multicast query that says, I want to print, who can help me?
Right.
And then you get back an answer from the devices that are printers, which for a typical home user is 1 or 2. In an office environment, it might be 10 or 20, but they're 20 separate devices with 20 separate replies giving the names of those services.
Well, in addition to that, you also have a browse capability built into a Dnssd where you can essentially ask for all services.
No, there is no wildcard.
Well, no, there isn't, but there is a list of all the pointer records associated with all the services built into Dnssd.
I don't know what you're talking about.
No, that list gets assembled from all of the individual responses that Stuart was just talking about. There's no one central location that gathers all of those PTR records.
Well, services...
They're all supplied by the individual devices that are returning the services.
I write about it in my draft, but there's services _ services,
Right.
blah, 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 where it's optional, but you can populate that with pointer records to all the potential services that are available.
Okay. You don't get a list of all the serviced instances. It is conceptually one level up the tree. So, and it's not used by any shipping software. It's a debugging tool, but as a network monitoring tool, you can ask for the list of service types that are present on this network. And then for each service type, you can then ask for the instances of that service. So if you look for service types on this network at the IETF, you might get a dozen or 20 service types. There might be printers, there might be peer-to-peer chat, there might be SSH, there might be a handful of things. For each one of those, you can then enumerate the instances of that type.
Right, but potentially that could create a fairly large RR set.
Which of those would be a large RR set?
Well, if you have pointer records, the 2 labels pointing to each service, that could potentially create...
When you say each service, do you mean service type or each instance?
Well, you have a service type, but then you have a breakdown of the service. And the 2 labels.
Let's not use the word service, because when we use the word service, printing is a service and Stuart's printer is a service. So let's say we'll call Internet Printing Protocol a service type, and we'll call terminal room printer an instance. So you're talking about service types or instances?
I think we're getting into some confusion, at least maybe or perhaps on my part. But when I look at how things get labeled, there seems to be some overlay between, say, host names being a service. Like if I want to find someone's laptop.
Well, no, so host names are not a service. Printing is a service.
I got that.
A service may be instantiated on a piece of hardware that has a host name. So that the order is IPP, Internet Printing Protocol, is a service type. terminal room printer is an instance of that service, and that service exists on a host that has an IP address listening on port 613.
Right, but the two labels you glom together in that response are going to be broken down into combining both of those together. So you could have a fairly large breakdown of potential host names associated with those services.
I'm sorry, I'm not following at all what you're saying.
Okay, I'll leave it alone.
Yeah, I think we'll need to take that conversation. If you can generate some examples and take it to the email list, we can discuss it there. Other discussion points on this draft today? So we have at least a couple of things that need to be done, not the least of which is implementations.
Yes.
Okay, thank you. Yeah, there we go.
Okay. The second document, which is the first one chronologically, but makes sense to talk about it second because one of the changes in this document is we now reference the push notifications as the preferred mechanism for delivering asynchronous change notifications to clients. And we also added this delivery of client configuration information via multicast DNS, which is a useful thing to co-locate. I had some discussions with Marcus Stenberg at the hackathon on Sunday, and I have some edits ready to go out in a -02, which I didn't submit right away because there wouldn't be time for people to read it anyway. So I also wanted to take this opportunity and see if there were other comments that should be incorporated. If there aren't, then I'll submit that -02 tonight. If people have other comments, then I'll endeavor to get those incorporated the next day or two and get draft 02 out. And then I believe we should be ready to do the last call. The things that I have planned, which are not published yet, is Marcus and I had some discussion about the text, about having rich text domains for service discovery, which mimic the old AppleTalk zone list, which were relatively unconstrained text, just like you're allowed uppercase letters and spaces and punctuation in file names. You should be allowed that for service discovery as well. And Marcus expressed the opinion that if you're not using host names on the command line, then spaces in host names actually work fine in the software. They're just awkward to type. So I've added some text discussing that issue. Marcus also very validly pointed out that the previous text was a little bit sloppy. It said send 3 queries and then return a negative answer if you don't get a response. And it didn't say what the interval between the queries was or how long you should wait. So I reworded that. I hope to be a bit more rigorous to say you should issue a multicast DNS query as per RFC 6762, following the retransmission schedule that is laid out there. And if you don't have an answer within 6 seconds, then you return a negative response. We can debate whether 6 seconds is the right number, but at least the document is unambiguous now. Marcus also questioned this issue of whether 10 seconds is the right maximum TTL to return in records. I added a paragraph of justification why I think that is a good number. In brief, it revolves around human interface, user experience aspects. If I'm trying to print and I can't print and it turns out somebody's turned the printer off, and I get on the phone and say, hey, can you turn that printer on for me? It typically takes on the order of 10 seconds for embedded devices to boot up and advertise their presence on the network. And it would be nice if that data were available in the DNS and cleared from caches within about another 10 seconds. I don't have to wait 5 minutes after somebody turned the printer on before I can use it.
Go ahead, Andrew, if you have a comment.
Andrew Sullivan. I don't care if you use this, but I will tell you that Dyn has done a bunch of measurement on effective TTL use in caches on the internet. And as far as we can tell, nobody pays any attention to TTLs lower than 30 seconds.
Okay, that is good information. One thing that may make a difference here is the target use case for this is enterprise networks more than it is internet-wide use. And one of my selfish motivations here is Apple is building a new campus. It's the famous Flying Saucer building. And we are planning to deploy this as the basis for service discovery in that new campus and actually get back some of the network browsing that we used to have 20 years ago with Apple Talk. So within our own enterprise, we can make our own decisions about what TTLs will respect and how much network bandwidth we're willing to devote to making this work, which is very different to what you might do on the public internet.
Right, and I wasn't trying to suggest that they don't work. It's just that they tend not to work on deployed things on the public internet. So it's worth noting that and telling people probably your software doesn't have this set right, so you need to set it down.
I will make a note of that. Thank you.
Yeah.
Tim Wasinski. As someone who has works in an enterprise company, we actually pay very much attention to that very low NX TTL. And we've done a lot of stuff internally and externally to play with that. So people do pay attention, but it's very few.
The DNS service discovery is building on the existing DNS protocol, but using it in a slightly different way. And when the DNS was dominantly host names, hosts tended not to come and go with great frequency, so long TTLs were appropriate. When your printer and your security camera and your home thermostat are announcing their presence dynamically, it's a more dynamic network than having your sysadmin type something into the zone file and SIG-hub named. So that results in more network traffic used by this management, and that's a question within a small home network that may still be a small amount of traffic. Within an enterprise, it may be an acceptable amount of traffic on your gigabit links. So that may argue for different timeouts being appropriate. Dave?
Dave Filler, just to second what Andrew said, we did a similar exercise 6 or 7 years ago and found exactly the same thing. And the focus there was primarily on like home gateway class equipment. And regardless of what TTL that you tell it from the outside, it's going to cache it for 30 seconds anyway. So again, it's just a data point to say for reference and what you do. And this might be different. That's okay, but it's good.
That's really useful information because the document ought to say that, because that is guidance for if you find things are not updating the way you thought they should, that tells you where to look to find out why. So same question for this document. And on this one, I'm more inclined to say, yes, I think we are ready for last call because we've all had a long time to think about the document and we have some implementations to validate it. Are you getting ready to make a comment, Marcus?
So let me interject here for a second. Channeling my co-chair, there are a lot of people in the room. We're going to start a working group last call when the document is revised. We have time to kick off the conversation now. If you have any comments that you think you might raise during a working group last call, feel free to bring them up now as a way of sort of getting that started. And then we'll continue it after the rev to the doc is published and we're ready for a formal working group last call on the mailing list. Marcus.
Markus Temari. Just a brief comment that I think that with those changes that you're proposing, it's probably ready for last call from my point of view. But of course, I would like to see the item first before I say anything. But from my point of view, this question is highly academic because this depends on PASH essentially, and that I don't consider to be ready for last call yet due to the lack of implementations. So
you are quite correct that if we do a last call successfully and it goes to the IESG for publication, we would end up with a down ref to a draft that's not finished yet, which is a good reason for us to move swiftly on the push notification implementation, which we are doing, we are working on that at Apple, and the plan is to have that done by the end of the year, and partly for our own selfish reasons, because we want this deployed in our new building, which is proceeding at a reasonable pace. We will not be building the enterprise gear ourselves. We're talking to our colleagues at Cisco and other companies to supply the Apple campus. So we need time for them to build this functionality into their hardware so that we can give them money to buy that hardware to put it into the new campus. So we're aware of the timetable that's ahead of us there if we want to make this real for our own selfish reasons. And of course, having deployed it at our campus, Cisco and Juniper and whichever other networking companies are then free to go and sell that same functionality to their other customers.
Andrew Sullivan, there were a few values in here, right? The 6 seconds and 10 seconds things that were, well, you know, what are the right values? Like these are the ones that seemed about right, but we don't really know. Given the time that we've got from the push stuff, is there any hope of, like, since people have some implementations, of running some experiments to see what the right values would be? I've been sitting here sort of trying to think of one, and I haven't myself, but maybe other people have a good idea for that. It'd be nice, right? I don't think it's critical. I do think, by the way, that this document is ready for last call, or assuming the changes, and then I will read them, but yeah. So it just seemed to me that might be nice to have if there was a way to do it.
Yeah, thanks, Andrew. My personal position is I would stand by the 6 seconds and the 10 seconds. I put that in the document because I would rather have a document be specific, even if it's wrong, than vague and let everybody make their own assumptions. Because by making it specific, if people object, then we can have that discussion rather than publishing an RFC that it turns out we actually don't agree on, though we thought we did.
Dave Taylor, question on the slide that had the 2 10-second numbers. So go back, I think is it one slide? Yeah, this one. No, yeah, that one. So the example that you gave about, you want the printer to appear after you've turned it on is about the negative caching TTL.
Correct.
And so that one, I think there's a really good argument is you want that to be as low as possible, and if 30 seconds is a problem, you should go and fix it, and so on. My question is really about the TTL, the positive answers, because that's really how long you want to stick there after you turn the printer off, right? And so if it doesn't disappear within 10 seconds, maybe that one's not that big of a deal, and that could be 30 seconds or something without causing problems. Or is there a reason that you want a very low number for the positive answer TTL?
It's not just turning it off, it's also rebooting it and getting a different DHCP address or something like that.
So it's a renumbering event of some
Yes.
sort. Comment on that one?
It's Markus Stenberg again. It's also mobility event, because when we have been demoing this stuff, there has been stuff happening in the network, and if the mobile node itself moves, then it will stick around as long as that positive TTL is valid. So from my point of view, I agree that it could be for many cases much larger, but not all. So that makes it hard. So I would prefer smaller numbers than bigger numbers here.
I'm just speaking from my own experience and just really sort of pulling numbers out of the air. In my experience, if I hit Command P to print and the print queue hasn't shown connected to printer sending document within, if it's less than 5 seconds, I'm not going to notice. If it's 30 seconds, I'm starting to click cancel buttons and do things. So somewhere between 5 and 30 feels like the right range for me personally.
Yeah, I think that's fine. It's just because we just talked about putting in some text that said, there's various 30-second cache minimum things that are out there, and to say, well, we'd like it to be 10 for the following reason, and yes, there's things out there that are 30. You could actually have 2 different discussions, one in the positive case, one in the negative case, about the effects of things that have capped it at 30 seconds in those 2 cases, and sort of caveats in the real world that you may run into some issues, and here's where to go and look to resolve them.
Okay, thank you, Dave. Seems like that is our final comment on that. So I will push the edited document that I have right now and give people a couple of days to take a look at it. And if nobody objects, we can kick off the last call. Now, with the comments that Marcus made, I think we can have a working group last call on the document as it is, while the push stuff is going through the court process of completing itself. I don't think it makes sense for us to send this for IETF last call until both of them are ready to go.
Okay. I think I agree. Thank you. Dave.
Okay, so some of you may remember a little over a year ago, IETF 90, there was a presentation on a document that's the one on the bottom there, where the presenter's flight got delayed such that he couldn't make the meeting, and so I presented it. And so I'm not going to be representing the details that's in that. What I'm going to be talking about today is primarily in what's in the other link there. And so again, why is it me standing in front of here? Keep in mind that nothing that I'm talking about, I'm an author on any of the behavior here, okay? I did do, along with one of my other Microsoft colleagues who's not here at IETF, an analysis of stuff, okay? Because we put an implementation of open source code into Windows, and so we had to analyze, well, we've got an MDNS compliant implementation, and we have this other all join stuff, and it has some different behavior. And so how does it interact? And so we tried to compare those to say, what are the differences, why are they different, and so on, okay? And so we went back to the authors of the implementation and asked them some questions, and I kind of report out to you some interesting things that we found, okay? So also, this hasn't been talked about since IETF 90 because the original author, the one who was going to be here to present at IETF 90, has changed jobs and is no longer working on this, and that's why the draft expired, okay? And so it needed somebody else to pick it up, and so I guess I'm kind of the stucky in between the two organizations right now. Think of it as like a liaison-like position, right? The way you get work done when somebody else wants something is you tell them to come and bring the work to the IETF, right? So I guess I'm the closest thing to a stucky in between, right? So that's why I'm here, okay? So me, Microsoft, would like to improve it, and the All-Seen Alliance that owns the code for this other thing is actually open to that, okay? Now they care about backwards compatibility, all the stuff that's out there, right? But they're actually open to making changes, okay? Oh, and of course, and we believe that there's some extensions that would be beneficial, and we'll talk about what that is and whether or not they are beneficial or not, we can talk about it. Okay. So I went back to them and I tried to retroactively reconstruct what the requirements were, right? I could tell what they built, I think, and what the requirements were. What problem were they trying to solve? Okay, here's my best guess at enumerating their set of requirements that they had going in. Of course, just the generic problem to efficiently enumerate responders that implement logical functions. Well, what's a logical function? Because I made that term up, okay? You know, thermostats, light bulbs, and so on. So each device or each IP address may have any number of these different things, okay? And all join, those logical functions are called interfaces, okay? Terminology aside, if I say interface, that's what it means here. They wanted to make it easy for vendors to mint their own things, interfaces, okay, at will, without having some, in a unique fashion, without having some central registry. And the way that they did that was basically using the DNS suffix as a namespace prefix or suffix or whatever. They wanted to support proxy responders, where the number one use case was maybe to non-IP links, like proxying from Zigbee or Z-Wave or something else, but also on sleepy nodes. They wanted to, now their scenarios were such that they only cared about the local subnet, and so they only did this for MDNS, not for DNS. Okay, so this is just MDNS. And all the use cases were for what we would call shared .local names, no unique .local names. Okay, so because everything was subnet specific and shared, they didn't see any need to do DNSSEC. Okay, so there's no DNSSEC. They wanted high reliability and low latency of enumeration on Wi-Fi links, and we'll talk about that. But of course, they didn't want to design it in a way that was specific to Wi-Fi either. They just wanted it to work well on Wi-Fi. They wanted to scale up to a very large number of responders with a large number of function types each, so that it could be used in like an industrial environment or something like that. The large number of function types each, if you think of a proxy, right, one device is proxying for a large number of things behind it, right? And that's where it might have a large number of function types on one device. And then finally, supporting multiple apps for some definition of app per IP address. And just a note that, well, they already have multiple service discovery protocols. They've already had 3 different iterations of it, so they had to deal with backwards compatibility. But on the good side, that means that adding another one, they already are sort of agile in terms of service discovery. So if we say, well, this thing isn't as good as what it should be, and you should be doing it that way, they're certainly open to that, right? They have to have a fallback for backwards compatibility, but they're absolutely open to say, and there could be a fourth version or whatever, okay? And so the link that I gave you at the beginning actually has a lot more than I'm talking about right now, because it also covers all the two deprecated variations and interop with them too, which is not terribly interesting because it's kind of deprecated. So if you go and look at that link, it has other interesting stuff too, but I'm not going to talk about it. I'm just going to talk about what's actually used instead of what's deprecated. Okay. So as you'll see, they did it as MDNS extensions. Now, why MDNS extensions? Well, this was really interesting, and I hadn't heard this before. So the quote that I got was, there was a brand of Wi-Fi router, very popular in Israel, and another in China that was causing problems. Okay. What were those problems? Well, the reports were that those APs would forward MDNS, or in other words, things on port 5353, and no other multicast port. That means if you want to do any service discovery of any type on the local LAN, you better make the query look like an MDNS query. So that's what they did. Okay, this is the ops, right? If you want it to work, you got to do ugly things, right? So that's what they did, I'm telling you. But I'd never heard this claim before. There were in fact APs that were observed to forward 5353, but no other multicast port. Okay, probably because I'm in North America and not in Israel or China, so I've never seen that. Okay, so that's the ops report. Okay, so now the problem with multicast, right? We always hear this thing, which is true, right? That multicast over Wi-Fi is very unreliable compared to unicast. And they wanted fast, reliable enumeration over multicast. So what do they do? Well, because MDNS is designed to work in an application, right? That you can do whatever you want in an application, right? Just like you can make things look like TCP to a middle box and do interesting things in, minion or TCP extensions, right? So what do? They said, well, for the queries, they do exponential backoff, and you can see they do sort of a 3x backoff. But at each one, they actually send a burst of three queries separated by 100 milliseconds each. Okay, so if one of them is dropped, it just tries it 3 times. So it's wham, wham, right? And then the next time out, wham, 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 100 milliseconds apart. Right? And that 100 milliseconds had to do with sort of the Wi-Fi wake-up times and so on that was observed to be a good number from their experiments currently. And so the responder only responds to at most 1 query per burst. So you'll see they have a way of detecting what's in the same burst, which is what's not. And the responses are always unicast because unicast is more reliable than multicast, right? So they just always unicast the responses. So I don't have to play any special games with the response. But in the response, of course, the issue is that, well, only one application can be listening on unicast port 5353. And if you want to support multiple applications, such as you got regular MDNS running in the box or in one application, you're doing this in a different application, you can't both share 5353, right? So they put a way in the query to specify send the unicast response to an alternate port. Okay, so the courier says, oh, and send the response back to this other port. Okay, so they had that as an extension. Now it actually supports either an alternate port or alternate address or whatever. It's kind of powerful enough to do that, but that's what they were trying to solve, to allow the multiple couriers on the same machine and then getting your response to come back to the right app. Okay. All right, so here's what the query looks like, and you can find the full details at the link that's up there if you find the section that's talking about the current thing and not the previous ones. But so the name is always alljoin underscore udp.local or tcp.local, one of those two. Okay, so all the queries go to the same name, and so in other words, what happens is that if an application is doing this, it's listening on basically just that set of names, and that names means it has this other behavior. So in that sense, it sort of ships in the night with a classic MDNS implementation, because a classic MDNS implementation will never have these names. Right? And so the classic MDNS implementation gets it and responds on 5353 whatever. And this other application might be also listening on multicast port 5353. And if it sees this, then it will respond in a different way. Okay? So these two applications don't really interfere with each other. So I said from operational experience, there's no interference with MDNS classic implementations because it's all on disjoint names. Okay? Or this is an INI allocated service name, right? All join. So I said this service name is reserved for the purpose of doing these extensions, right? And so in the additional section, they want, because all the queries are to the same names in what they did, but they wanted to have a large number of logical functions and say, okay, enumerate all the thermostats or all enumerate all the light bulbs and so on. But they only got one name. So what they did is they put the filter in TXT records, and so in the query section, in the additional record section of the query, there's txt records. It has, well, here's the actual function name that I'm looking at. So in this case, it's org.alljoin.about. You notice that it has the reverse DNS suffix or alljoin.org as the uniqueness namespace. And in this example, it's the about, which happens to be kind of a required one for each interface. And if you have multiple of those, they end them together in terms of whether or not to respond. And to say, how do you encode the other two issues that we talked about, which is how do you specify the alternate port to respond to, and how do you tell which messages are in the same burst versus which is different bursts. There's txt records with a different name, this sender info thing that has a way of encoding in these sort of name value pairs to say, here's the burst ID, here's the alternate port to respond to. If this is absent, that means use the regular port. Okay, so that's how they extended the query. There are some extensions in the response, of which only one of them is actually kind of relevant anymore, which is the first one, which is the sender info. It's the same one in the query, which is the alternate port thing. All right, so the responder can say, oh, and here's an alternate port that goes directly to me. And so this is, if I want to do unicast queries in the future, right, like for liveness or whatever else, then here's the alternate port you can unicast query me on, right? Because the regular 5353 is going to be used by the MDNS implementation. If I want to do something here to get to this app, right, I got to use the alternate port. So the responder can say, oh, and here's the same sender ID text record in the response as the courier puts in it. It's the information about yourself, right? So the responder is saying, here's my alternate port. And the other two are for deprecated concepts that don't really exist anymore, and so you can kind of ignore them, but you'll find them there in the document for backwards compatibility because the previous version used them for something interesting, but they're not used anymore. So nowadays, it's pretty much just the first one. Okay? So that's how they extended the queries and how they extended the responses and how they ran it sort of ships in the night on a different port number, except for the multicast still has to listen on 5353 to get the initial query. Okay, so that's what they did. The draft that was put together that's now expired was saying, well, how could we take this concept of the filter part of it, which was this part where you'd have like org.alljoin.about or thermostat or light bulb or this long list of things that the responder might have a long number of them and the courier might also have a long number of them. You want them to scale up and have vendors be able to put in their own namespace there, like com.microsoft.com, or pick your favorite light bulb vendor, and so on. And so that was kind of their use case for why they said, why would we want to put TXT records or filters in the query? Okay. But this notion of putting a filter in the query isn't specific to all joins, so this draft was written more generically, and that's what was presented at IETF 90. And there was some discussion about why we use TXT records in the query in the draft, which is not all join specific, right? And the answer was that, well, you've already have to have in an MDNS, Dnssd implementation, the ability to deal with TXT records with name value pairs, okay, and a responder and so on. And so, especially if you're thinking about implementations of things like this in a very small device, then just being able to reuse the same code and TXT record parsing and TXT record formation makes the code very easy, right? It scales down to constrained devices. So that's why they said, we're going to put very simple filters and not do complex stuff, right? Because we don't care if there's a couple of extra queries. What we're trying to do is we're trying to prevent every possible device that's out there, like if there's 100,000 different devices, including those that are being proxied for, right? Then they want to get it down to a small number that are actually just the thermostats, not all the other things in the industrial environment, okay? Or the home environment, although probably we don't have that many in that environment. And so the simple queries was seen to be good enough to reduce the multicast traffic, reduce the transmission requirements on responders that only have to wake up and send a response and generate transmission power for the things that are highly likely to match. And if a couple of extra things get through, like there's some false positives, yeah, you'll just respond and they'll get dropped on the courier side anyway when he does the more complex filters. Not a big deal. It's just an optimization to cut down on traffic. And so the responder optionally uses them. So in other words, it's sort of backwards compatible, because if you don't pay attention to these TXT records, you're just going to over-respond just like you do today. Okay? So it's just an optional optimization. Yeah. Okay. And so here is the exact set of minutes from IETF 90 and the exact one Jabberlog comment that's there's no editing in here. And so if I just go through to prevent people from getting up the mic or to encourage you to get up on the mic if this is one of your thing and refresh your memory as to what you said. Tim Chone was just talking about the charter and how this is actually in scope for discussion, even though there's not a milestone. And so it is appropriate for discussing in the working group. Tell me if I get yourself wrong. Tim, too, said that the technology might be problematic with DNSSEC. Yep. And the use case was one where I explained their applicability was such they didn't see a need for it because the applicability was only for shared .local names on a local subnet. Now, when the draft was written, the draft said maybe there's some extension to unicast DNS, but I think the feedback was, well, maybe not. Stuart said, gee, this query language looks a lot like SLP, and we know how well that went. Paraphrasing, yeah. Andrew Sullivan, I think sarcastically added at that point. Yeah, Andrew confirms that it was indeed sarcastic. Well, clearly we can just use NAPTR records or something, right? And so that's why I mentioned that the goal was the simplistic query to be able to scale down to constrained devices and to just reuse the TXT record code that's already present. And having strict filters is not a requirement because it's just an optimization. And if you don't want to do it, you don't have to, but the optimization is useful enough. Okay. Dave mentioned that the notion of subtype filtering, I think this was a comment that said, yeah, he liked the direction it was going because it solved a problem for him, is how I read that, or how I remember that. And Carrie Lynn, I don't know what SEP is, or if that was a typo for SLP, I'm not sure. I don't know if Carrie is here somewhere. And then finally, the chairs mentioned that they want to see discussion further on the list. So that's my prep to not have to repeat all the discussion from last time. That's what we talked about before. And you see I've covered the responses to those in my discussion. Okay, so next steps. There are 3 possible extensions or 3 ways that they extended MDNS. So the question is the working group interested in the IETF doing any of these 3 types of extensions? Okay. The first type was, and again, this is whether or not it's done the way that AllJoin did it or some way that we might think is better. Okay. The question is the working group interested in any of these 3 topics? Okay. The first one is optimizations over Wi-Fi, where multicast is not terribly reliable compared to unicast. Okay. Is that an interesting problem to the working group? Number 2, the notion of an alternate unicast response port so that multiple applications on the same host with the same IP address can all be using MDNS at the same time in an efficient fashion. And number 3 is the one that the draft currently covers, which is an individual submission from an author that kind of went away, which is putting simple filters and queries for shared .local names. And so assuming there is at least interest in the third one at least, then the resurrecting the expired draft would be necessary and need a willing author, and I guess I'm a potential stucky if there's interest in doing that. So those are the 3 topics, the 3 questions to the working group. So at this point, this is my last slide, so general discussion.
Thanks for doing all this investigation, and thanks for a really interesting presentation. I had no knowledge of any of this. I'm particularly happy to find that there are Israeli routers that only pass bonjour packets, because that's a nice reversal of the normal state of the world.
Yeah, exactly. I was surprised to hear that too.
Yeah, that's the first time I'd heard that. Some of the, it's interesting, some of the things here seem to be things that were already in the MDNS responder code, and it's not clear to me whether they were not aware of that or whether for some reason they needed a different way of doing it. One example is with the current shipping code that's on these machines around here, if you send a multicast DNS query where the source port is not 5353, then they will send a unicast response because they can tell that's a different client application that's not the system service running on the system port. So there is already some support in there for unicast responses.
That one, again, I'm not authoritative on any of these answers, but my guess is their reading of the spec, not the code, their reading of the spec led them to believe that that was not the case.
That may be the case.
They probably said, our reading of the spec is that it says that you must listen on 5353, and they didn't find any place else that said anything else, and so they said, well, then therefore we got to extend it. Again, that's my guess.
Yeah, you may be right. The 13927 3x exponential backoff actually also matches the MDNS responder code, which they may have got from the open source code,
I
which
think
was
the exponential backoff part, but not the burst of 3 at a time, right?
the burst of 3 at a time is a new invention.
Yeah.
And
Right. The 1.3 whatever isn't called out in the spec explicitly. It just says, well, you have to have at least an order.
it says at least doubling,
2x.
which we did in the early versions of the code, and we later went to 3x in an attempt to reduce the traffic level, which actually segues nicely into my next point.
So yes, I believe they did copy the 1.3 whatever
Right.
actually from what they observed. Yes.
And the reason we went from the normal traditional networking powers of 2 to powers of 3 was frankly a bit of an act of desperation to try to get the multicast traffic levels down, because particularly on Wi-Fi, where multicast is not acknowledged, I expect most of the people in this room already know this, so I apologize. Wi-Fi access points will send at the lowest rate. They'll pick the lowest common denominator to maximize the chance that everybody gets it, which makes multicasts extraordinarily expensive in terms of the airtime they consume. So one unicast to me at a gigabit per second, or 1.3 gigabits per second, is an infinitesimal blip of the airtime. But a multicast at 6 megabits per second is 100 times more expensive in terms of the shared medium it's consuming. So to do that 3 times is 300 times as wasteful. So given that one of the major criticisms of Bonjour is it's too chatty and it floods my Wi-Fi network with too much multicast, to say, yeah, let's do that 3 times as much, really worries me. If Wi-Fi multicast needs to be more reliable, then that seems like the job of the Wi-Fi link layer to figure out how to make Wi-Fi multicast more reliable, because on my switched Ethernet hub, I don't need to send it 3 times. So to send it 3 times at the IP layer without actually knowing what the link layer is, and to do that, to make the unreliable link layer more reliable when that's already the one that is suffering most from the multicast burden. I mean, arguably my gigabit Ethernet switch could take a lot more multicast and not even worry about it. It's the shared network here at the IETF that's really suffering.
So before you go on, I'm going to attempt a guess at what they would say. Same reason as people run stuff over UDP, right? You're an app. You can't change what the stack does. You want to make your app work if you're an app vendor, right? You can't wait for somebody else to do stuff. You got to do what you can to get your scenarios to work. And they were trying to minimize the latency. So my guess is they probably wouldn't care about that argument. They would do it anyway for the same reason that people do stuff over UDP today.
If I put my cynical hat on, it made their app work better, and Bonjour got blamed for being chatty, so it wasn't their problem.
I'm still Ralph Drums. I think it's even worse than Stuart just described, because there are, I believe now, so I'm a failed mathematician, not a network hardware guy, so I'm guessing at this, but my understanding is there are optimizations built into some Wi-Fi gear that try to do a better job of getting multicast across, and that I'm sure will play badly with a burst of 3 packets as described here. So it just seems like a really bad idea all the way around.
You notice that one was not in the internet draft, but it's here for completeness. Yeah. Stuart, you more on that one, or you want to go on your next?
I have one more point to wrap up, which I'll do quickly because it's kind of a reiteration of the SLP comment you made. But looking at the internet draft about the queries, they give examples of like color equals true. Well, not all color printers are the same, right? There's the cheap $49 inkjet printers, and there's the nice ones that have got the 6 color cartridges or the 8 color cartridges with the gloss optimizer. So color is not true or false. There's a quality level of, I want good glossy color, not crummy color. So I think if you go down this path of wanting queries, simple equality is probably not going to be enough. You probably want greater than, less than. You want to be able
so I would say, I don't believe that they believe that. I can tell you that I don't believe that either. But the discussion that happened around last IETF, in other words, on the list in between the times the draft was posted and IETF, was who specifies what those name value pairs is, which is very close to your question. And the answer was the expectation, and it wasn't in draft 00. This is where the author said, I'll put it in the draft 01, and then he went away before putting it in there, was to say that the whoever specifies the service name, and so in this example, the service name was, underscore all join or whatever it is up here. Whoever specifies that is responsible for saying what the name value pairs is for that service name.
Although actually in this example, all services are all join. It's the thing in the text record that says what the actual service is. It's which is sort of an odd thing because
that's why I didn't call that one a service, right? I called it an interface or a function type or whatever, because you can imagine other implementations that actually don't use a single name and that use something about some way of encoding the hierarchical function name into that. But the problem in MDNS is you only have one label, right? You can't have an arbitrary number of labels there. And so you need some interesting scheme that we have, in fact, been discussing when Microsoft reviewed it. Says, why did you do it that way? We can think of better ways to do that wouldn't have the same problems and so on. And so there is potential for evolution there.
So I'm going to break in here for just a second, point out that we have 5 minutes left in the meeting. And I would like to have some discussion at a level up that says, what do we want to do with this? So,
okay,
Stuart.
Then I will wrap up.
Okay.
Yeah. Samita Chakrabarti. I think without going the details in the solution, in the problem space, looks interesting to me. Not only on Wi-Fi optimizations, but also on the constrained node networks. So if you are considering other kind of networks such as 802.15.4 or other networks that 6LoW I'm concerned about are working with, then I think we need such DNS discovery solution. But how exactly the solution would be, whether this one or not, that is debatable.
So the meta question is not about doing something the way that AllJoin did it. The meta question is about, is this problem an interesting way to solve it? And should we do the IETF way of doing things? It says, if you want to solve problem A, B, or C, depending which one or ones we might want to do, what is the recommended way to do that? Okay, if it isn't already done, to Stuart's earlier point, yeah.
Okay, so let's see, I'm trying to determine what to do. Let's see, based on the discussion, it seems like there is interest in talking about the problems that were put forward. We don't know exactly, and I don't think we have time today to determine which of those three, if any, we might want to try to tackle. So, Stuart?
I have a question on this subject.
Yep.
It seems like the original author of this has moved on.
Yep.
So the question is, it sounds like what David is saying is that Microsoft has interest in developing things in this area, which the current technology does not meet those needs. So to
clarify, we don't like having two different implementations that are gratuitously different trying to share the same protocol because it just bloats the code or whatever.
No
and we would like there to only be one and not two.
Okay.
And so that is our interest because we currently have two and we don't like that.
Right. So
so in addition to solving these three things, there's that meta problem you want to try to solve, which is not.
It's equivalent to the alternate unicast response port problem, but actually it's not. That's a subset of it because.
Yeah, I was going to say. So there's implicitly a fourth one, and is it just Microsoft or is it Allseen and Microsoft?
I would say Microsoft is driving the reason to try to get the two to converge and not do stuff gratuitously different. The other ones I would say are more in follower mode because the only person that was kind of driving this before changed shops, right?
Okay,
so now everybody else is in follower mode that says, yeah, we would be happy to do that. Please go do the work for us.
And let me just get one more clarification. So Allseen has already adopted the version that you've described in that document that I glanced at but didn't read thoroughly. And what Microsoft is trying to do is get from that to something that's better converged. On
the very first slide, there was two links.
Yep.
Okay. what is in the open source code and shipping in many different places is the first link, which is the link to the All-Seen Alliance that says, here's what the code does, okay? Which is most of the presentation I did this time, okay? The internet draft is not exactly what happens. It's an attempt to generalize that into something slightly more sane, okay?
Okay.
But what's actually shipping is everything at the first link. And shipping by a bunch of different vendors and things.
Okay, so go ahead.
Given that we're out of time, I'll be very brief. In the IETF spirit of rough consensus and running code, if we are talking about solving a problem for the sake of solving a problem, then I don't have a lot of energy for that. But if what I'm hearing from Dave or anybody else is we want to build and ship real products that use this or something like it, then I'm happy to help with that effort to produce something real.
We already have running code and we'd like to make it be better, right? That's here.
Andrew Sullivan, I guess to answer your question on the third one of those, which is about those filters, I guess the question that I would have is how much appetite is there for doing that in a less, in a more extensible way. It seemed the question that Stuart asked right after it struck me as like, that's exactly what's going to happen. And I can just imagine an explosion of piggishness there. So it seems to me that that thing is an attractive nuisance unless there's a fairly significant change to the way it works. The other two, I don't care.
Okay, thank you. Thank you. Obviously, continue this on the mailing list. I'm going to give a quick summary. Oh, Terry.
Putting on my AD hat, Terry Manderson, responsible AD. There's actually some words in the charter to say it's really great to document these problems, but working on the solution isn't really within the bounds of the scope. So we can have a sidebar meeting on that and really nail out what that means.
Okay.
And have a chat, okay?
Great, thank you. Brief summary. We're going to do a working group call on the next revision of the hybrid proxy doc, and then that will park until the push notification doc is done. We're going to, Stuart's going to revise the push notification. We're going to see if we can get some additional implementations. Go to working group last call when we have interoperable implementations. And then once both of those go through working group last call, they're coming to you, Terry. I don't think we can adopt the threats document yet. That needs at least one more rewrite to address the issues that were brought up today. And we are going to consider and discuss on the working group exactly what to do with the concepts and the documents that Dave talked about. Okay? And that'll do it. Thank you very much.
Oh, also,